Hello, my name is Daniel, and today we will be going through the AMC 10B from the year 2020, so let's get started. First problem, what is the value of this thing? Okay, so we will just do this. This is just 1 plus 2 minus 3 plus 4 minus 5 plus 6. So this is 1, 1, and 3. So 3 plus 1 plus 1, this equals 5. So the answer is D. Number 2, Carl has 5 cubes, each having side length 1, and Kate has 5 cubes having side length 2. What is the total volume of these 10 cubes? Okay, so 1 cube of side length 1 is going to have volume 1. So 5 times 1 plus 5 cubes of side length 2, right? So 5 times 2 cubed, and that is 8, right? So this is 5 times 9 equals 45. So the answer is E. Number 3, the ratio of W to X is 4 to 3, the ratio of Y to Z is 3 to 2, and the ratio of Z to X is 1 to 6. What is the ratio of W to Y? So we have W and X, they are 4 to 3, and then the ratio of Y to Z, they are 3 to 2. And then the ratio of Z to X is 1 to 6, right? So for this to be 1 to 6, then 1 to 6 is equal to 2 to 12, right? And that's to match this 2. And so if this is 2, then Y will be 3. And if this is multiplied by 4, so this is times 4, that means the W value is also times 4, so that will be 16, right? We want the ratio of W to Y, and so that is 16 to 3. The answer is E. Number 4, the acute angles of a right triangle are A degrees and B degrees, where A is greater than B, and both A and B are prime numbers. What is the least possible value of B? Okay, so since A and B are the acute angles of a right triangle, that means A plus B equals 90 degrees, right? Because they are parts of a right triangle, and A is greater than B, and both A and B are prime numbers. Okay, so we have to separate 90 into two prime numbers, and so they will be an odd number and an odd number, right? Okay, so first we can have, so first we can have 3 and 87, but then 87, this is a multiple of 3, so that won't work. And next is 5 and 45, but that is, but 45 is also a not a prime number, so that also won't work. And if B is 7 and A is 83, this works because 83 is a prime number and 7 is a prime number, so the least possible value of B is 7, so the answer is D. Number 5, how many distinguishable arrangements are there of 1 brown tile, 1 purple tile, 2 green tiles, and 3 yellow tiles in a row from left to right? Tiles of the same color, they are indistinguishable. Okay, so we have 1 brown tile, we have purple tile, we have 2 green tiles, and 3 yellow tiles in a row. Okay, so we have seven kind of slots, so 7 slots. 7 slots. And first, let's see where the brown one will go. So that's 7, choose 1. And then multiply that by, we have 6 slots left. And of those, we will see where the purple one will go. So that's 6, choose 1. And then of the 5 that's left, we will choose where the green one will go. And so that's times 5, choose 2. And then the left one is just Y. So if we want to write that, that's just 3, choose 3. But that's just 1, so we don't have to write that. So let's just take it out. And so this is what we want to calculate. This is obviously 7, this is obviously 6, and this is 5, choose 2, that is 10. So 7 times 6 times 10, that gives us 420, so that is the answer, it's B. Number 6, driving along a highway, Megan noticed that her odometer showed 15951 miles. This number is a palindrome which reads the same forwards and backwards. Then 2 hours later, the odometer displayed the next higher palindrome. What was our average speed in miles per hour during this 2-hour period? Okay, so let's find the next higher palindrome first, and that will be 16061, right? And so let's calculate the distance from 15951 to 16061. So that will be 16061 minus 15951, and so that will be equal to 110 miles, right? So in 2 hours, she went 110 miles. So 2 hours, 110 miles. So in 1 hour, she will go 55 miles, right? So 1 hour, she went 55 miles. So her average speed in miles per hour, that was 55 miles per hour. So the answer is B. Number 7, how many positive even multiples of 3 less than 2020 are perfect squares? Okay, so first it said that we want even multiples of 3. So that means this is a multiple of 2 and a multiple of 3 at the same time. So that means it's a multiple of 6, but then they have to be perfect squares, so they have to be multiples of 36, right? And so so if the perfect square, this would be something like 6k squared, right? Because the 6 is there because they have to be even multiples of 3, and this has to be perfect square, so it should be 6k squared, kind of like that, right? and it has to be less than 2020. But then we know that 45 squared, this equals 2025, right? So that means 44 squared, no, yeah, so since 45 squared is 2025, and that means 44 squared, this will be less than 2020, obviously, right? This is like 1936, I believe. And so that means 6k can be less than or equal to 44, but then this has to be positive, so k can't ever be negative, right? And so let's count the number of k values that can be that are possible. K is less than or equal to 44 over 6. This is 7 and 2 over 6, right? And so the positive even multiples of 3, there are 7 of them, because k can be either 1, 2, 3, 4, 5, 6, or 7. So we have 7. It's A. Number 8, points P and Q lie on a plane with PQ equals 8. How many locations for point R in this plane are there such that the triangles with vertices PQ and R is a right triangle with area 12 square units? Okay, so we have a line PQ, right? PQ, and this is 8, but then the area has to be constant, right? So the area has to be 12 square units, but then there are there are two possible right triangles that can happen right here, right? So there is a right triangle with a right angle at P or Q, right? So this will be 8, and so this length would be something like, what is it? It's 3, right? And so that length could be 3, and so there's this kind of right triangle, or yeah, so there's this kind of right triangle, or there could be a right triangle with the right angle at here, right? And so that way, so that way, this length times this length, that would be right angle, right? Yeah, sorry, that would be 24, right? And this would be 3, right? And so we have this kind of triangle with the right angle on the outside, and this has the right angle on the P and Q, right? If we kind of make all of these possibilities into a diagram, then that would look something like this, right? So there will be 4 of the first kinds of triangles, like this, and like this, and like this, and they would all have their right angles on either P or Q, right? And there are the second type of triangles, like this, right? So we have this one, and we have this one, and we have this one, and we have this one, right? So there are 4 types of the second type of triangles with the right angles not on P or Q, right? And so in total, we have 8 locations for point R, and they are 1, 2, 3, 4, 5, 6, 7, 8. So those are 8 locations. The answer is D. Number 9, for how many ordered pairs of integers x, y satisfy the equation? This one. Okay, so for this one, since this is y squared equals 2y, that means x cannot get too big, right? Because 2020 is an even number, so x to an even power, and y squared, this is this cannot, so this is positive, and so x, if x is like, so if the absolute value of x is like greater than 2, then it's not possible, right? Okay, so if x is 0, that just gives us y squared equals 2y, and so y can be either 0 or y can be 2. And if x equals 1, then this is 1 plus y squared equals 2y, and so y can be 1, right? But then x being 1 just means x to the 2020th is equal to 1. And for this to equal 1, x can also be negative 1, right? And this just an integer, so it can be a negative value, so y is equal to 1 also in this case. And so we have 0, 0, 0, 2, 1, 1, and negative 1, 1. We have 4 ordered pairs of integers. The answer is D. Number 10, a 3/4 sector of a circle of radius 4 inches together with its interior can be rolled up to form the lateral surface area of a right circular cone by taping together along the 2 radii shown. So it's this one and this one. Those two will be taped together. What is the volume of the cone in cubic inches? Okay, so if we make if we make a cone out of this, then it will look something like this. And if you see this this whole circumference will be equal to this length right here, right? So the circumference of the cone will be equal to 3/4 the circumference of the circle, right? So this much will be 3/4 times 4 times 2 times 4 times pi. So this equals 6 pi, right? Okay, so this is 6 pi. That means right here, this much, that radius is 3, right? So the radius is 3, and this is 4, and that is this length, right? So that's equal to that length. This is 4, and so now we can get this length by the Pythagorean theorem, and so this length equals root 4 square minus 3 square equals root 7, right? And so the volume of the cone in cubic inches, that is the height, root 7 times the base, which is 3 squared pi, so 9 pi times 1/3. So this is 3 root 7 pi, so the answer is 3 pi root 7, it's C. Number 11, Miss Carr asks her students to read any 5 of the 10 books on a reading list. Harold randomly selects 5 books from the list, and Betty does the same. What is the probability that there are exactly 2 books that they both select? Okay, so we can just look at the probability that Betty overlaps with Harold, right? So we can just look at the probability that Betty selects 5 at random, and at random Betty overlaps 2 with Harold, right? With Harold, right? So this will be equal to, if Betty selects 5 at random, that will be just 10 choose 5, right? So that will be 10 choose 5. And then Betty overlapping 2 with Harold, that will be, first we will have to do 5 choose 2, because this is for Betty selecting 2 books from Harold to overlap with. And next we have to do 5 choose 3, because Betty has to choose 3 books from the books that Harold did not choose, right? And so that would give her 5 books with 2 overlapping with Harold. And so if we do this, this is equal to 10 choose 5 is 10 times 9 times 8 times 7 times 6 over 5 times 4 times 3 times 2 times 1. And then this is all under 5 choose 2 is 10, 5 choose 3 is also 10, right? And so now we can cancel here. So 10 and 10, they cancel, and then 1 cancels by itself. 6 and 3 times 2 cancel, and then 8 and 4 cancel, that to make 2. And then 5 goes up to 10, right? And so this is equal to, so this is equal to 10 times 5 over 9 times 2 times 7. And so 10 and 2, they can cancel to make, 5, right? So they can cancel to make 5. So this is equal to 25 over 63. The answer is D. Number 12, the decimal representation of this consists of a string of zeros after the decimal point followed by a 9 and then several more digits. How many zeros are in that initial string of zeros after the decimal point? Okay, so we can divide this into it being 1 over 10 to the 20th power times 1 over 2 to the 20th power, right? And so we know that this has 20 zeros. And now we only have to find out the number of zeros that this one has. And we all know that 2 to the 10th power is 1024. And from that, if we square 2 to the 10th power, like that, this will be 2 to the 20th power, right? This will be 10,024 squared. And since 10,024, this is a 3, this is about 10 to the 3rd power, then this will be about 10 to the 6th power, right? Because it's 10 to the 3rd power squared. So it will be about 10 to the 6th power. And so if we do 1 over 2 to the 20th power, this will be about 1 over, so this will be similar to 1 over 10 to the 6th power. So this will have 6 zeros, right? So that will have 6 zeros. So this has 6 zeros. And in total, we have 20 and 6. So we have 26 zeros. It's D. Number 13, Andy the ant lives on a coordinate plane and is currently at negative 20, facing east, that is in the positive x direction. Andy moves 1 unit and then turns 90 degrees left. From there, Andy moves 2 units north and then turns 90 degrees left. He then moves 3 units west and then again turns 90 degrees left. Andy continues his progress, increasing his distance each time by 1 unit and always turning left. Where is the location of the point at which Andy makes the 20th left turn? Okay, so let's say that Andy starts at this point, and this is negative 20, then he would go east 1 unit, and then he would go 2 north, and then he would go 3 west, like that, and then 4 south, like that, and then, so he would go 4 south, and then he would go 5 east, and then 6 north, stuff like that, right? So Andy makes his first left turn here, I'll do it in a different color. First left turn here, second left turn here, third here, fourth here, fifth here, and sixth here, right? And so if we keep going, this will go on. Notice that after this point, right, the distance between the previous layer and the next layer, this is going to be always equal to 2, right? So this 2, this 2, this 2, this 2, right? And so that's one pattern that we notice. And then one more thing we notice is we want the 20/20th left turn, so we want when this number becomes 2020, right? But then right now we can see that this is the middle is the 0th, so the middle is the 0th turn, right? So this is the first turn, this is the 0th turn, and then we can see that as we go to this direction, it increases by it increases by 4, right? And so each kind of jump, each increase of 4 is going -2 and then -2 more, -2 and -2 more, -2 and then -2 more for x and the y-axis, right? So we want 2020. So 2020, this is 4 times 505, right? And so 505 times 2 equals 1010, right? So what this means is that from this point it will go 1010 down and 1010 left, right? And so 1010 down, and left, right? But then we started at -20, 20, and so we have to add from so we have to add this to -20 and 20, so -20, 20, and these are going in the negative values, so -1010, -1010. So this will be equal to -1030, -990, right? So this will be the answer. It's B. Number 14, as shown in the figure below, 6 semicircles lie in the interior of a regular hexagon with side length 2 so that the diameters of these semicircles coincide with the sides of the hexagon. What is the area of the shaded region inside the hexagon but outside all of these semicircles? So we want this area right here. And to get this area, all that we have to do is we just have to make some lines like this. And so these will be the lines we need. And now we can see that to get the shaded region, we can just get the area of this Star of David here. And then we can subtract 6 of these kinds of fan shapes, right? So first we can get this whole thing. And since we know that this whole thing is 2, we know that one side is 1, so this is 1, right? And so we know that one of this equilateral triangle, so one triangle is √3/4 times 1 squared, so this is √3/4, and so we have 1, 2, 3, 4, 5, 6, and then inside we have 6 more, so we have 12 of those in total, right? So this times 12, so √3/4 times 12 equals 3√3, right? So we have 3√3, and we have to subtract these 6 of these fans, right? And so if you see, you can see that each fan is 1/6 of a full circle, right? And so if we have 6 of those, then that's just going to make a full circle. And so if we get the number, and so if we get the area of one circle, the circle is going to be just pi r squared, which is pi times 1 squared. This is pi, right? And so we are doing 3√3 minus pi, so that is D. The answer is D. Number 15, Steve wrote the digits 1, 2, 3, 4, and 5 in order repeatedly from left to right, forming a list of 10,000 digits beginning 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, like that, right? He then erased every third digit from his list, and then erased every fourth digit from the resulting list, and then erased every fifth digit from what remained at that point. Where's the sum of the 3 digits that were then in the positions 2019, 2020, 2021? Okay, so first of all, the digits, they started with 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, like that, right? And then he then erased every third digit. So that means we have 1, 2, 4, 5, 2, 3, 5, 1, 3, 4 left over. But then for this next thing, this number sequence, they repeat, right? Because if you see this 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, this was repeating, right? And so the same numbers will have been erased for each like block of like 3, for each block of 3, 1, 2, 3, 4, 5, right? And so this block, still continues, right? And the next, he erased every fourth digit, so these are left. But then same thing, this also is this also like repeats, right? Because previously we saw that these were repeating, and so if we group two of these into one block, then that block would have continued, right? And so the same numbers would also have been erased, just like the first one, just like this one. And so that means this thing is just keeps repeating. And then from this one, we have to erase every fifth digit. And also same thing, this was being repeated. And so this is also going to be repeated, right? And so this is a list of 12 numbers. 12 numbers, they are repeating, right? And we want the positions 2019, 2020, 2021. And so if we just have the remainders of these numbers when they are divided by 12, then we can just pick and choose. Yeah, then we can just pick and choose from these numbers. And so if we do that, 2019, if we see, then it has a remainder of 3. Remainder of 3, then this one has a remainder of 4, then this one has a remainder of 5, right? So our remainders are 3, 4, and 5, and so we need to choose the third, fourth, and fifth number from this sequence. So the third and fourth and fifth is 4, 2, 5. So those are the 3 digits that are in these positions. So if we add them, 4 plus 2 plus 5, this equals 11. So the answer is 11, it's D. Number 16. Bella and Jen play the following game on the closed interval 0, n of the real number line, where n is a fixed integer greater than 4. They take turns playing, with Bella going first. At his first turn, Bella chooses any real number in the interval 0, n. Thereafter, the player whose turn it is chooses a real number that is more than 1 unit away from all numbers previously chosen by either player. A player unable to choose such a number loses. Using optimal strategy, which player will win the game? And looking at the answer choices, we have to compare when n is odd or even, and when n is greater than or less than 8, right? Okay, so let's compare it when n equals 8 and n equals 9, because that will solve all our problems, right? And so when n is 8, then we have 0, 1, 2, 3, 4, 5, 6, 7, 8, right? And Bella chooses first. Bella goes first. And so Bella would choose 4, right? Bella would choose 4 because that is the optimal strategy. And then Jen can choose either 7 or 6, because choosing 7 is the same as choosing 1, and choosing 6 is the same as choosing 2. And of course you can choose 8 and choose 0, but that won't be optimal strategy, right? But then whatever Jen does here, so say if Jen goes there, then Bella can't go anywhere here, so Bella has to go here. And then if Bella goes here, then Jen loses, right? If Jen goes here, then Bella can go here, here, or here. And so if Bella goes here next, then Jen will have to go to either one of these two places, and then Bella will go to the last place, and then Bella will also win, right? And so this always results in Bella winning. And if n is 9, let's see, we have 0, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And then Bella would, and then Bella always goes first, so Bella would go somewhere here, right? 4 or 5, anywhere of those two, because they are symmetrical. And then Jen would go here, right? Because this has more lengths. Then Bella would go either 7 or 9, right? So let's say Bella goes to like 9, right? Then Jen will have to go either 7 or 0 or 1, right? And if Jen goes here, then Bella can go anywhere of here and he will win. If Jen goes here or here, then Bella can just go here and Bella will also win, right? So that means that this also results in Bella winning, right? And so obviously B is wrong. Jen will not always win, and Jen will win if and only if n is greater than 8. No, Jen lost, right? So E is also wrong. D is also wrong, right? Bella will win if and only if n is odd. Ben won even when n is even, right? So C is also wrong. That means A is correct. Bella will always win. Number 17. There are 10 people standing equally spaced around a circle. Each person knows exactly 3 of the other 9 people, the 2 people standing next to him or her, as well as the person directly across the circle. How many ways are there for the 10 people to split up into 5 pairs so that the members of each pair know each other? Okay, so we have a circle, and we have 10 people standing equally spaced, right? So we have 1, 2, 3, 4, 1, 2, 3, 4, like that, right? And each person knows exactly 3 of the other 9 people, and so we so these people can pair up in in 4 different ways, right? So first is pairing up by the people who are at the sides, right? So people who are at the sides only. Right, so that would be, if we choose this person to be the center, that would be either this, or that would be this, right? Those are 2 different so those are 2 different ways to split up. So this gives us 2 ways. And next is for one pair to pair up across from each other, and the rest pair up with the people at their sides, right? So that will look something like this, like that, right? But then for this we have 5 choices, right? Because this across line can go either here, 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 or here. So those are the 5 choices. And so so if we take this away, so that would just give us 5 choices. And then the next is if we have 3 across, and that just means that we are going to have 3 people like this who are going to be across from each other, and then the remaining 2 people will be at their sides, right? We'll be partners with the people at their sides. And so for this one also we have 5 choices, because we have to determine where the center line will go, so where the center pair will be. So will it be this pair, 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 or will it be this pair? So those are the 5 choices. And so this is also 5 choices. And lastly, we can have just all 5 pairs be across from each other, right? Be across from each other, and that will just be like this pair, this pair, this pair, this pair, and that pair. So that will just be one possibility. So if we just add all of these up, 2 plus 5 plus 5 plus 1, this is 13. So the answer is C. Number 18, an urn contains 1 red ball and 1 blue ball. A box of extra red and blue balls lie nearby. George performs the following operation 4 times. He draws a ball from the urn at random, and then takes a ball of the same color from the box and then returns those 2 matching balls to the urn. After the 4 iterations, the urn contains 6 balls. What is the probability that the urn contains 3 balls of each color? Okay, so first, so at the beginning, the urn contains red one and blue one of each. But then after 4 iterations, it has 6 balls now. But then there needs to be 3 balls of each color, so there needs to be 2 more red, and 2 more blue, right? And so for this to happen, it can just happen in any order, because the probability will just stay the same, right? And so that will be if we get red and then blue and then blue, right? So if we get red first, that will be choosing 1 over 2, and then if we get 1 more red, then that will be choosing 2 over 3, right? So this is times 2 over 3, and then now no more reds, we have to get blues, right? So that will be choosing 1 over 4. 1 over 4, and then lastly this will be choosing 2 over 5, right? So that will be choosing 2 over 5, but then we don't know which order that these red and blues will come in, right? So it can be like red, blue, blue, or it can be red, blue, or it can be red, blue, blue, red, like that, right? And so these are 4 choices, and we have 2 that are the same, so we can just do 4 choose 2, and then that will settle the problem for us, right? So this gives us these 2 cancel, and then 4 and 2 becomes 2, and then 4 choose 2, this is 6, right? So that becomes 6, and 3 and 2 cancel with 6, so then only 1, and then 1 cancels, and so only 5 is left, so that gives us 1 over 5. So the answer is B. Number 19. In a certain card game, a player is dealt a hand of 10 cards from a deck of 52 distinct cards. The number of distinct unordered hands that can be dealt to the player can be written as this monstrosity. What is the digit A? Okay, so a player is dealt a hand of 10 cards from 52, right? And so we want the number of distinct hands, but then that's just 52 choose 10, right? So if we write down 52 choose 10, that will be this monstrosity, right? So let's just write down 52 choose 10 in like a multiplied form. So 52 times 51 times 50 times 49 times 48 times 47 times 46 times 45 times 45 times 44 times 43 all over 10 times 9, 8, 7, 6, 5, 4, 3, 2, 1, right? And so this is going to be equal to 158A00A4A0, right? Okay, and then first of all, let's get rid of this ending 0. So if we divide by 10 on both sides, then this will just become 5, this will just become 5, and this will just become A. And so now what we can do is we can try to simplify this, and then we will just get the units digit of that, right? And because the units digit will be A, yeah, and so the A is the units digit of simplified number, right? And so let's get simplifying. So 1 gets out, and then 44, yeah, no, and then 5 they get they're away, and then 6 times 8 is 48, they go away, and 7 times 7 is 49, so we have 7 left. And 44 times 4, so these two cancel, and then we have 11 left, and then 40, and then 52 and 3 cancel, so that gives us, what does it give us? No, yeah, actually 52 and 2 cancel. Yeah, so 52 and 2 cancel, so that gives us 26. And now we have 3, 9, and 10, and so for 10, 45 and 10 cancel to make 2 and 9, right? But then if we do 9 and 3, then that gives us remainder of 3, right? And then for 2, we can just use it up on 46, and so that will just give us 23 as our remainder, and we have 9 left over. And if we divide by 9, 51 divided by 3, 51 divided by 3 is 17, so we have 3 left. And lastly, to use the 3, where do we have? We can make that go away, and so this 3 will go away. And so lastly, if we just list the things that we have left in red, we have 17, and we have 47, and we have 43, right? And so we want the units digit of everything this multiplied together. And so if we just go and count the units digit, this would be 6 times 7. This becomes 2, and so 7 times 7 would make it 4 because of 14, and then 14 times 47, that will make it 8, and then 8 times 3, that's 24. So it's going to be 4. 4 times 1 is just going to be 4 again, and then this is just going to be 4 times 3, so it's 2. So the units digit is 2. This is 2, so the answer is A. Problem number 20. Let B be a right rectangular prism box with edges length 1, 3, and 4 together with its interior. For real r is greater than or equal to 0. Let SR be the set of points in three-dimensional space that lie within a distance r of some point in B. The volume of SR can be expressed as AR cubed plus BR squared plus CR plus D. This one, where A, B, C, and D are positive real numbers. What is BC over AD? Okay, so we have a rectangular prism like this here. Yes, so we have the rectangular prism like this, and then this is going to be like 1, 3, 4, like that, right? But then this can be expressed in AR cubed plus BR squared plus CR plus D, and so what this means that it's going to be the set of points in three-dimensional space that lie within a distance r of some point in B. That just means that there is going to be like so there is going to be like a set of kind of like cylinders and like rectangles that will go like that, and then these are going to be added together to the overall volume, right? And so this is just two sides of it, and then we go and then I hope you don't get confused, but this side is going to stick out like that, and then going to make a rectangular prism like that, and then it's going to connect like that and like that and like that, right? And then same thing for the other side. This is also going to be like that, and going to be connecting like that, and so like that, and then it's going to connect like that and like that also, right? And like that and like that, and like that, right? So I don't know if you understood that, but hopefully you did, and I will also draw this again later when I am solving these things. Yes, when I am solving for kind of each value, right? So I will draw it again, and hopefully that time you will understand. Okay, so first of all, let's solve for D. D is just going to be like the full volume of the so D is just going to be the volume of the prism itself, because all the other things that just has this much length is R, right? And so that's just all gonna have R in them. So D is going to be the constant, and so that's just going to be 1 times 3 times 4. This is 12, right? And the next C, this is the C times R, right? And so that is just if you see here, that's just going to be these kinds of like these parts, right? And so there will be one on top and then one on the bottom, like that, and then one at the front and one at the front, like that, and one at the back, like that, right? And all and there are two on and yes, and there are also two on the sides having this as the face, and then it's coming out by R, right? And that's also true for this face over there. And so this is just going to be the surface area times R. So this is the surface area times R. Yeah, but that's CR, right? So just C is going to be the surface area. So this is 1 times 3 plus 3 times 4 plus 1 times 4, all times 2. So this is 3 plus 12 plus 4 times 2. So this is 19 times 2, which is 38, right? So this is 38. So D equals 12, C equals 38, and then now we have to get to D. No, we have to get to B, right? Yeah, so B is the coefficient when we have R squared factor, and so that's going to be something like this, right? And so these will all come together to make one full cylinder, right? One full cylinder like that, and then it will appear to have been like sliced like that. And so this radius is R, and the height of the yes, and the height of the cylinder, that will just be this, right? That, right? And so that's just R squared times height, which is like one of the lengths, right? So that would be like 3. And then the same thing would happen for all the other edges as heights, right? And so these 4 would come together to make this kind of cylinder, like that, right? And so this would have height of 4, right? Plus 4, and then and then this is R, so it's all R, and so it's all R squared. And then lastly, and so this is going to come together to form a cylinder that looks like this, and it's going to be like this. And so this is going to have height of 1, so this is plus 1. So this is 8R squared, and so B equals 8, right? B equals 8, because this is B. And then lastly for A, A is R cubed, right? And so so A is the coefficient of R cubed, and so that will be just something like, and so these will all come together to just make one full sphere. And so the radius of each thing would be R, and so the volume, this doesn't look like a sphere, but it kind of is, and so the volume would be equal to 3 over 4, no, 4 over 3. 4 over 3 times R squared, no, R cubed pi, and so this times this, so 4 pi over, so 4 pi over 3, A equals 4 pi over 3, right? And also, sorry, but B has to be 8 pi, and so now we want BC over AD, right? So we can take this away, and now we can get BC over AD. BC over AD, this will be equal to, B is 8 pi, and then C is 38, over A is 12, and D is 4 pi over 3. And we can take out this over 3 with 4 here, and so that will be 16 pi times 19 over 16 pi, so this is 19. The answer is B. Number 21. In square ABCD, points E and H lie on AB and DA respectively, so that AE equals AH. Points F and G lie on BC and CD respectively, and points I and J lie on EH, so that FI is perpendicular to EH and GJ is perpendicular to EH. See the figure below, triangle AEH. So triangle AEH is this one. And then quadrilateral BFIE. BFIE, this one, quadrilateral DHJG, this one, and pentagon FCGJI, so this one, they all have area 1. What is FI squared? So we want this so we want that length and squared. So first thing we know is that this is 1, 1, 1, 1, and so that means that the total area is going to be 4. So total area is going to be 4, and so that means this much is 2, and this much is 2, right? So first of all, this is 2, and then next we can draw a line from A to C, like that, right? And we can draw a line from G to F, like that. And so that will give us that since AHE this has area 1, that means the square will have area 2, and so this has area root 2, right? So this much is root 2, and so that means this length is going to be 1, so this much is going to be 1, right? But then now let's say that this length is A, and this length is B, right? And so FI would be B, and this half length would also be A and A, right? And so the next thing we can get is that this full diagonal that is 2 root 2, right? And so 2 root 2 is equal to A plus B plus 1 is equal to A plus B plus 1 right? And then we can get one more thing, and that is we can use the fact that this area is 1, right? And so this area is this rectangle plus CGF this triangle, right? And so the so area 1, this is equal to 2A times B, so that's this, and plus this much, and that's A squared, right? 1 equals 2AB plus A squared. And so FI squared, this is B squared, right? And then using these two things, we can solve for B, right? And so from this one, we can see that A plus B equals 2 root 2 minus 1, right? And then we can split that into A times A plus 2B, right? And so this is A plus B minus A plus B minus B times A plus B plus B, right? And so since we know A plus B values, then we can just plug this in. So this is 2 root 2 minus 1, 2 root 2 minus 1, and then minus B, times 2 root 2 minus 1, and then plus B, right? So this equals 2 root 2 minus 1 squared, and then minus B squared, and then this equals 1. So this equals 1, and so B squared equals 2 root 2 minus 1 squared minus 1, and so this is 8 minus 4 root 2 plus 1 minus 1. So these two cancel, and so B squared equals 8 minus 4 root 2, but then we were looking for B squared all along. So the answer is 8 minus 4 root 2, so the answer is B. Number 22, what is the remainder when 2 to the 202nd power plus 202 is divided by this? Okay, so let's say that A equals 2 to the 50th power, right? Then this one would be that would be 4A fourth plus 202 equals, this is so equals 2A squared plus 2A plus 1, like that, and then we have something multiplied, and then we have a remainder, right? And now since this is in A form, then we can just get what this is, right? So to make 4A squared, we need 2A squared, and then since there is no A cubed or A squared or A term, that means we're going to have minus 2A, and then we're going to have plus 1, right? And then to make the constant 202, we're going to have to add 202 at the end. And this is the remainder. No, sorry, that's not the remainder. The remainder is 201, right? And so this is the remainder. That's what we've wanted. So the answer is 201. It's D. Number 23. Square ABCD in the coordinate plane has vertices at these points. Consider the following four transformations: L, R, H, and V. But then this H and V, those are because of like the horizontal and vertical. But then because this is x-axis and y-axis, let's just say it's x and y for easiness. Each of these transformations maps the square onto itself, but the positions of the labeled vertices will change. For example, applying R and then V will send the vertex A at 1, 1 to negative 1, 1, and will send the vertex B at negative 1, 1 to itself. How many sequences of 20 transformations chosen from LRHV will send all of the labeled vertices back to their original positions? For example, RRVH is one sequence of 4 transformations that will send the vertices back to their original positions. Okay, so if we draw a coordinate plane very small, then A would be, then this would be A, this would be B, this would be C, and this would be D, right? And that would be D, right? But then right now, things are pretty similar for A and C, and they are also pretty similar for B and D, right? And so for a certain number of transformations to make the point come back to itself, then we need at least 2, right? And so let's kind of try it with A. And so if we have A, then we can first apply to it L, R, X, and Y, right? So H of V is just X and Y. And so A to the left is B. So it's so A to the left is B, and then A to the right is D, and then A by X is also D, and A to the Y is B. Right, so it's BDDB, and then now let's do this LRXY one more time, and then so we will be doing LRXY to B and D, right? So for B to the left is C, and then B to the right is A, B to the X is C, B to the Y is A. And then for D, left is A, and the right is C, and then A, and then C, right? And then since this is D and this is B, we can just put the same thing in here. This is AC, and CA, right? And so if you look at this, we start from A, and then this is 2 transformations, and then we come back to A exactly 1/2 of the time, right? And this means that it needs an even number of transformations, right? There is a half chance of coming back, right? So when we have an even number of transformations, A has a half chance of coming back, right? And since A and C are basically in the same position, this is for A and C, right? So for C also, if it comes back to A, then it comes back to C, right? But then we don't know about B and D, right? So next, let's try it with B and D. So we have B here, and then we'll just do the same thing. And then here also, we also notice that for B to come back to B, we also see that we come back to B half of the time. So if we have an even number of transformations, then there's a half chance of coming back to B, right? Coming back, and then this applies for B and D. This applies for B and D, right? And so in total we have, since this is a 20 transformations, and that is an even number, we have half chance of A and C coming back, and we have half chance of B and D coming back, right? But then since we have 20 transformations and we have 4 to choose from, we also have to multiply this by 4 to the 20th power, right? So this is 4 to the 19th power, and this is equal to 2 to the 38th power. So the answer is C. Number 24, how many positive integers n satisfy this? Okay, so here, let's say that n equals 70x plus 50, right? So we're setting n as 70x plus 50 because that is the least number for which this will be like an integer value, right? And so if we put this into there, then that will give us all over 70, and 70x plus 1050, this equals x plus 15, right? So x plus 15 is the floor of root n, right? And floor of x is the greatest integer that doesn't exceed x. This came up a lot before, so you should know this by now. Yeah, so x plus 15 equals the floor of root n, right? But then since n is just this, we can just substitute n into root 70x plus 50, right? And since the floor of root 70x plus 50 is x plus 15, that means root 70x plus 50 is greater than or equal to x plus 15, but it's less than x plus 16, right? And so this will give us that x plus 15 squared is less than or equal to 70x plus 50, right? Because we squared both sides, and that will give us x squared plus, no, that will give us x squared plus 30x. Yeah, so plus 30x plus 225 is less than or equal to 70x plus 50. So x squared minus 40x plus 175 will be less than or equal to 0. And if we factor this, we get negative 5 and negative 35. So x can be 5 or 35. And so since this is an inequality, that gives us x is greater than or equal to 5 or less than or equal to 35, right? So this is our first kind of restriction, and for this one, we can say that x plus 16. No, sorry. Yeah, so 70x plus 50. So 70x plus 50. This is less than x plus 16 squared. So 70x plus 50. This is less than x squared minus 32x. No, plus 32x. And then plus 256, right? So if this goes over there, then we will get x squared minus 38x plus 206. This is greater than 0, and so x, and so factoring this, we get no, that can't be factored, right? And so I'm using the quadratic formula. We get x equals 15 plus or minus root, no, not 15. We get x equals 19 plus or minus root 155. And so that means that x is less than 19 minus root 155, or x is greater than 19. X is greater than 19 plus root 155. So that is our second restriction, right? And since if we kind of calculate root 155, that's between 12 and 13, right? So this is going to be, yeah, so this is going to be about 6 point something, and this is going to be about like 31 point something, right? Because root 155 is between 12 and 13. So x is less than 6 point something, x is greater than 31 1 point something. So this we have as one condition, and this we have as the other condition. And so the x that and so if we combine those two things, then we get x is greater than or equal to 5 but less than 6 point something, and yeah, or x is greater than 31 point something but less than or equal to 35. So x can be 5, 6, 32, 33, 34, 35. So we have this much, which is 6 values. So the answer is C. Last problem, number 25. Let Dn denote the number of ways of writing the positive integer as a product n equals this much. Where k is greater than or equal to 1, the fi are integers strictly greater than 1, and the order in which the factors are listed matters, so two representations that differ only in the order of the factors are counted as distinct. For example, the number 6 can be written as 6, 2 times 3, and 3 times 2, so d6 equals 3. What is d96? Okay, so let's start by writing out some values of d. D1, this D1 doesn't exist because fi has to be strictly greater than 1. So D2, we'll start from D2. D2, this is 1 because we just have 2. D3, we just have 1 because that's a prime number. D4, we have 1 plus D2, right? So this is, no. D4, we have 2 times 2 and 4, right? 2 times 2 and 4, so that gives us 2. And D5, this is prime, so this gives us 1. D6, this is 2 times 3, and it's 3, right? And you could keep going, and you will find the pattern that Dn, this is 1 plus D of D of something plus D of something plus D of something plus D of something and plus D of something, and all these things are going to be so the things in these are going to be all the factors of D, no, of n, right? of n, right? And so if you see d4 here, this is going to be 1 plus d2, and so d2 is 1, so that's just 2. And same for d6, 3, so this would be 1 plus d2 plus d3, so this is 3, because this is 1 and this is 1, right? And so in this kind of way, we can get d96 by listing all the factors of 96 and then getting the d's of all of them, right? So let us start from the top. So we will keep the 2, 3, and 4, and then next what we want is d6, right? This is 3 as was given by the problem, and then we have d8. This is so this is 1 plus 2, so this is 1 plus d2, so this is 1, no, this is 2, and d9. d8, this is 1 plus d2 plus d4, so that's 1 plus 1 plus 2, which is 4. And d9, this is 1 plus d3, so that's 2. d8, that's just going to be 1 plus d2 plus d4, so that's 4. And then what we want next is d12. d12, this is 1 plus 1 plus 1 plus 2 plus 3, right? So that's 1 plus 1 plus 1, 2 plus 3, which is 8. So that's 8. Yeah. And then next we want d16. d16, this one is 1 plus 1 plus 2 plus 4, so that is also 8, right? Then next we need d24. This equals 1 plus 1 plus 1 plus 2 plus 6 plus 8 plus 12, right? And so 1 plus 1 plus 2 plus 3 plus 4 plus 8, that will become, what is it? That becomes 20, right? Because this much is 19. So that becomes 20. And then next we want d32, right? 32, this is 2 to the 5th power, so that's just 1 plus 1 plus 2 plus 4 plus 8. So that gives us 16. So d32 is 16. And d48, this is 1 plus 1 plus 1 plus 2 plus 3 plus 4 plus 8 plus 8 also. And then we have to add d24, right? So all of those combined, we get 48. So this is 48, and so that's the 48. And then if you see, these are all the factors of 96, right? 2, 24, 32, and 48. So those are all the factors of d96, and so d96 equals 1 plus all of these added together. So so all of these added together until 20 was 48, right? So we have 48 for until d24, so this is 48, and then we have 16 here plus 48 here. So this equals 17 plus 48 times 2. This is 17 plus 96. This is 112, right? So no, sorry, that is 112. Yeah. So the answer is A. So that was it for problem number 25. And thank you for watching.